This is a video on C2 chemistry from the AQA syllabus on acids, bases and salts. Okay, so the key things that we need to know about in terms of acids, bases and salts are to do with the fact that there are three main things that we can react acids with to actually make salts, to make soluble salts. So remember, if something's soluble, that means it can be dissolved in water, it can be dissolved, okay, in whatever substance that referring to it to be soluble in. So it could be soluble in ethanol or soluble in water. If it just says soluble, assume soluble in water. But before I do that, very quickly, just need to remember the state symbols. So we've got solid, liquid, gas, and aqueous over here. Right. So soluble salts can be made from acids by reacting them with metals. Okay. So not all metals are suitable. Some are too reactive and others are not reactive enough. So there's a certain a number of metals that actually are reactive enough for this to take place. Insoluble bases. Okay, so that's where a base is added to an acid till no more will react, and then the excess solid is filtered off. And you've got alkalis as well. Okay, so alkalis, you use an indicator to see when it's actually reached neutral, when you've mixed, when you've had a neutralization reaction take place between the acid and the alkali, and then you've got a salt solution produced. Now, from that salt solution, from any of these salt solutions, okay, you can actually crystallize a salt from it. Okay, so the way to do that generally is via evaporation. If you evaporate it slowly, you'll end up with large crystals, and quickly you'll end up with small crystals. So quickly would be something on a Bunsen burner, would be evaporating using a Bunsen burner, and slowly would be putting on a windowsill. Right, so insoluble salts can be made by mixing an appropriate solution of ions so that a precipitate is formed. So precipitates are that solid that you have at the end of a chemical reaction. So you might mix two chemicals together and you end up with a solid. The most common one is actually when they're treating water, to move impurities in the water, and you end up with a solid behind afterwards that they then filter out. So that's a precipitation reactant, they're called. Okay, so it helps to remove unwanted ions from solutions. Right, so let's talk about some of these bases in a bit more detail, and naming salts in a bit more detail. So if you've got metal oxides and hydroxides, okay, are bases. If a base is soluble, if a hydroxide is soluble, we call it an alkali. Now, the salt that you get will depend upon two things. Number one, the acid used, and number two, the base stroke alkali used. So the acid tells you part of the name, the back part of the name. So hydrochloric acid gives you chlorides, nitric acid gives you nitrates, sulfuric acid gives you sulfates. The front part of the salt comes from the base or the alkali. And it's the metal within that. So to give you an example, if I was to mix copper sulfate, let's just say, no, sorry. If I was to mix copper, let's just get this right, with, let's say, HCl, hydrochloric acid. If this was copper oxide, sorry, is what I should have said in the first place, or copper hydroxide. My mistake. Right, I shall end up with water, which is always produced from this chemical reaction, but also copper from the metal part of the base, and chloride from the acid. Okay, so copper chloride. Oops. Okay, plus water. Okay, so now I messed it up at the start. I'll go for that again. If I had copper oxide plus hydrochloric acid, I'll end up with copper chloride plus water. So the copper part comes from the metal, okay, in the base used, or the alkali used, and the chloride part over here comes from the fact I'm using hydrochloric acid. If that was nitric acid, it would be nitrate instead. If this was nitric acid, that would be nitrate instead. Okay, right. So ammonia. So another one we could talk about. So we talked about the three acids over there. Ammonia is an interesting one to also talk about. Ammonia dissolves in water to make an alkali solution, and when you make salts from that, they're always called ammonium salts. Okay, so ammonia, when dissolved in water, produces ammonium salts. They're quite important. Okay, they're very, very important in the idea of fertilizers. Also, remember when you got hydrogen ions, they're positive, and you find them in acids. They make solutions acidic. Okay, so H plus makes solutions acidic, and OH minus the hydroxide ion makes solutions alkaline. When you mix those together, because remember the charges cancel out, that's a +1, that's a -1. When you cancel those out, you end up with 2 H's and 1 O, so that's H2O. And that's why all of these chemical reactions, all of these salt-producing reactions lead to water being produced as well. Remember, the pH scale is a measure of how acid or alkali a solution is. Remember, when you neutralise, as we were just saying, water is always produced because of this reaction over here. H plus OH minus leads to a H2O. Okay, right, so there should be a little arrow in there saying leads to H2O. Right, so electrolysis. Okay, electrolysis only works with ionic substances. Okay, so it's only if you've got an ionic substance. Okay, and it needs to be melted or it needs to be dissolved in water. Okay, that means that the ions are therefore free to move. Okay, throughout the solution or the liquid. Okay, so what that actually means is that you can actually have an electric current flowing. If you have the flow of ions, you end up with current flowing. So in other words, if you've got a molten substance like lead bromide, the solution will break it down into the elements. That's lead and bromine. That breaking down process is known as electrolysis. So electrolysis is a decomposition of a compound using electricity. The compound you're decomposing, the compound you're breaking down, is called the electrolyte. That's over here. So during electrolysis, positive ions go to the negative electrode and negative ions go to the positive electrode. Remember, you can use your data sheet, which will tell you which ions are positive and which ions are negative. You can also use the idea of electrolysis to electroplate objects. So the main electroplating that we actually have is copper plating and silver plating. There's a variety of reasons from that, from aesthetics to preventing rust, for a variety of reasons. Okay, so the negative electrode, positively charged ions gain electrons by a process called reduction. And at the positive electrode, negatively charged ions lose electrons via oxidation. It's a bit messy there, so I'll write this out at the top. There's an easy way of remembering this, okay? There's an easy way of remembering this process, and it's called oil rig. I'll write it up over here. Oil rig. So oxidation is losing, reduction is gaining. Okay, so oxidation is losing. So oxidation is losing electrons, and reduction is gaining. Reduction is gaining electrons. So remember, that's at the positive side. If it's gaining electrons, it must be negative already, so it's going to happen at the positive ion. It's going to be talking about positive ions. And if it's losing electrons, it's going to be talking about negative ions. Right. If there's a mixture of ions, the products formed depend upon the reactivity of the elements involved. So you've got to consider the reactivity. Okay. Now you can find that again on a data sheet. So you've got to think about which one's more reactive, and that will be the substance involved. And finally, we've got to talk about half equations. The best thing I can say about half equations is look them up online. Bite size is a very good section on the website about it. It's only for high tier students, but you've got to remember that charges need to be balanced on both sides of this. Okay, this is twice the negative, so you've got to end up with twice the negative on this side somehow as well. And the way we do that is by having 2 electrons. Similarly, over here is twice the negative there, and then you've got another twice negative here. But if you're taking them away, it ends up being positive. Aluminium is actually produced using the process, or manufactured using the process of electrolysis of a molten mixture of aluminium oxide and cryolite. It forms at the negative electrode and oxygen at the positive electrode. So the positive electrode needs to be made from carbon, because that's going to react with the oxygen and therefore make carbon dioxide. Electrolysis of sodium chloride solution, so that salt solution, produces hydrogen and chlorine. Sodium hydroxide solution is also produced. That's important specifically for making soap. Okay. Chlorine is used, so sodium hydroxide is used for soap. Chlorine is used for making plastics like PVC and also bleach. Okay, that is the end of the C2 videos.